In this lecture, we will be seeing another example of conversion of epsilon NFA to NFA. So we have our question given here, that is to convert the following epsilon NFA to its equivalent NFA. So we have an epsilon NFA given here. We see that epsilon symbols are used, and also there are three states here, P, Q and R, where P is starting state and R is the final state. And also there are three input symbols in this NFA, A, B and C. So we will convert this to its equivalent NFA. So I have already drawn the transition table. We have states P, Q and R and inputs A, B and C, and we have to find the epsilon closures for inputs A, B and C, since there are three input symbols. So let's start with the first state, that is P. So P's epsilon closure, P on epsilon can go to P itself, it can also go to R, and also it can go to Q. That means P on epsilon closure can go to P, Q and R. And where does P go on input A? P on input A doesn't have any move, so it goes nowhere, that is to phi. And Q on input A, where can it go? Q on input A, it goes to P. And R on input A also doesn't go anywhere, so it is phi over here. So here this will be phi, and P epsilon closure, what will it be? It will be P, Q and R. We already found out, so let me just write here P, Q and R, and since this is phi, there will be nothing over here. So the final states that we get here are P, Q and R. So that means P on input A will go to states P, Q and R in our NFA. Okay, so let's do the same thing for input B. P on input B. So epsilon closure of P is P, Q and R, and P on input B, where does it go? P on input B goes to Q, and Q on input B, where does it go? It goes to R, and R on input B doesn't go anywhere. Now epsilon closure of Q is only Q, because Q does not have any epsilon symbol here, and R's epsilon closure is also only R, and this is phi, so there will be nothing here. So the last states we get are Q and R. That means P on input B will go to Q and R. Now let's do the same for state C. For P, P's epsilon closure are P, Q and R, and P on input C, where does it go? Input C, it goes to R, and Q on input C goes to Q itself, and R on C doesn't go anywhere. Now epsilon closure of R is only R, and epsilon closure of Q is also only Q, and this is phi, so nothing here. So we get R and Q over here. That means Q and R. So P on input C will go to Q and R. Alright, so now we are done with state P. Now let's do the same for state Q. Q on input A. So epsilon closure of Q is only Q, and Q on input A, where does it go? It goes to P, and epsilon closure of P is P, Q and R. So finally we get P, Q and R. So Q on input A will go to P, Q and R in the NFA that we will be making. Now Q on input B. So let's write Q here. Q's epsilon closure is only Q, and Q on input B goes to R, and R's epsilon closure is only R. So that means here we will have only R. And let's do the same thing for input C. Q's epsilon closure is Q. Q on input C goes to Q itself, and epsilon closure of Q is Q. So here we have only Q. Alright, so let's do the last one, that is state R. R's epsilon closure is R itself, and R on input A doesn't go anywhere, so we get nothing here. So that means R goes to phi in input A. And what about R on input B? R's epsilon closure is R itself, and on input B it doesn't go anywhere. That means it is phi. And R on input C also, its epsilon closure is R itself, and R on input C doesn't go anywhere, so we get nothing here. That means it is phi. Alright, so now we have got the states for our NFA. Now the question is, what will be the final states here? So here R was a final state, so this R will definitely be a final state even in this. And will we have any more final states here? Let's check it out. So we see that P on epsilon, it can reach R. So any state that can reach the final state only on epsilon will also be a final state. So P will also be a final state, And what about Q? Q just by epsilon cannot reach the final state R, so Q will not be a final state. So here we have got the transition table for our NFA. So let's draw the transition diagram for this NFA that we have obtained. So we have states P, which is final state as well as the initial state, and we have state Q over here, and we have state R here, which is also a final state. Now let's see, P on input A, it goes to P, Q and R. It goes to P itself, it also goes to Q, and it also goes to R, that is on input A. Okay, and then P on input B, where does it go? It goes to Q and R. It goes to Q and R. So instead of drawing another line, I'll just write here B. That means on input B also it goes to Q, and on input B it also goes to R. Alright, and then on input C, where does P go? It goes to Q and R. So I can write input C also here. Okay, now let's come to state Q. Q on input A, where does it go? Q on input A goes to P, Q and R. So it goes to P and it goes to Q itself, and also it goes to R. That is on input A. And P on input B, where does it go? It goes only to R. So on input B it goes to R, and on input C it goes to Q itself. That means on input C it goes to Q itself. I can write C over here. And R on input A, B and C, it doesn't go anywhere, it is just by itself. So now we have completed the NFA. We have drawn the transition diagram for the NFA, which is equivalent to the epsilon NFA that was given in our question. So I hope that was clear to you. Thank you for watching and see you in the next one.